Every possible piece of information on the universe known to humanity is accumulated in the computer I reside in. As we freely peruse the voluminous digital data stored here, let's track down the true face of the Sun, the star most familiar to humankind.
This is Kitt Peak in the state of Arizona in the United States. Kitt Peak, on which the domes of 24 huge telescopes are lined up, is one of the key locations for astronomical observation in the world. Among them is an oddly shaped telescope. It is the McMath-Pierce Solar Telescope, the largest solar telescope in the world. Above the 30-meter-high tower is a plane mirror 2 meters in diameter, which automatically tracks the Sun. The light from the Sun captured here is guided into a tube at a 32-degree angle obliquely downward. Then it is reflected on the bottom of the 150-meter-long tube, built deep into the Earth and sent to the observation room. By doing this, the focal distance becomes longer, enabling a 90-centimeter diameter image of the enormous Sun to be produced in the observation room. Moreover, it is said that the resolution of the McMath-Pierce Solar Telescope is equivalent to having the capability of deciphering newsprint from a spot more than 10 kilometers away. This is a complete image of the Sun captured by a telescope on Earth. The diameter of the Sun is 1.4 million kilometers. It is 109 times larger than Earth. Called a photosphere, its temperature is 6,000 degrees Celsius. The places that appear dark are sunspots. The diameter of a sunspot is about 10,000 kilometers. One of them is large enough for the Earth to completely fit into. Sunspots may appear dark, but they are not really black in color. The temperature of sunspots is about 4,500 degrees Celsius. In comparison, the surrounding temperature is approximately 6,000 degrees. Because the temperature of the sunspots is 1,500 degrees lower, they just appear darker in contrast. If a sunspot was cut out and placed in the same spot as the moon, it would appear to shine more brightly than a full moon. Let's magnify the photosphere even more. The light and heat produced in the interior of the Sun gushes out in succession like a spring. These are called granules. The size of a single granule is about 1,000 kilometers. Japan's northern island of Hokkaido would fit completely inside. Next, let's look at the surface of the Sun through a special filter called an H-alpha. What we see is a stream of blazing hydrogen gas. This region is called a chromosphere. At a fierce speed of tens of thousands of kilometers an hour, the gas is spewed into outer space. The amazing activity of the hydrogen gas in this chromosphere spreads out unabated. These are explosive phenomena called flares that occur on the surface of the sun. It is said that the explosive energy of flares is equal to several billion times that of a nuclear explosion. In the space of mere seconds, the temperature can climb to several million degrees Celsius. This is a prominence, a column of flame rising up from the surface of the sun. Prominences are a high-density gas that erupts from the sun's surface in great quantities. The flames are several hundreds of thousands of kilometers high and can attain a size capable of swallowing up a planet 10 times the size of Earth. Some prominences die out after a few hours, while others last for several months. A corona spreads around the outside edge of the photosphere. A corona has an extreme temperature of 1 million degrees and is a flow of high-energy matter bursting off the surface of the sun. However, it is so rarefied that it is only visible when the sun's rays are obstructed, such as during a complete solar eclipse. The sun brims over with a multitude of phenomena. The sun is the mother star that rains life's energy on all living things on planet Earth. To us, the sun has a special and precious existence. However, of the countless stars that shine in the night sky, it is no more than a very ordinary, everyday star. Knowing the true face of the sun is also the first step in discovering the macrocosm, the world of the stars.
Why do sunspots exist? And how do prominences occur? Many huge solar telescopes have been invented by human beings in order to explore the true face of the sun, the mother star. However, observations from Earth have their limitations. As a result, there are currently various types of solar observation satellites that track the sun from outer space. One of these is the Solar and Heliospheric Observatory, or SOHO. SOHO is loaded with 12 varieties of observation equipment with which it repeatedly captures completely new features of the sun. Next, let's look at the fruits of that research.
SOHO is a solar observation satellite launched jointly in 1995 by NASA, the National Aeronautics and Space Administration, and ESA, the European Space Agency. Poised in outer space, 1.5 million kilometers in the sun's direction from Earth, SOHO observes the appearance of the sun, invisible from telescopes on Earth, 24 hours a day. This is NASA's Goddard Space Flight Center not far from Washington, D.C. in the United States. SOHO's observations are controlled entirely from here. Every day, an enormous amount of data, as much as 1 gigabyte, arrives from SOHO. New features of the Sun are depicted in the most recent data. This is the Sun as photographed by the EIT, the ultraviolet telescope loaded onto SOHO. 1 day has been reduced into approximately 20 seconds. Most ultraviolet rays are absorbed by the Earth's atmosphere. As a result, it is impossible to observe the Sun with ultraviolet rays using telescopes on Earth. However, by using 4 different ultraviolet wavelengths, EIT can observe it. What we see here is the Sun, as seen with ultraviolet rays given off by helium gas. The phenomenon of the demarcation line shifting to the corona from the top part of the Sun's chromosphere is being captured. In the vicinity of the Sun's North Pole, fine needle-like things violently fluttering are visible. These are called spicules, or jet flows of very hot gas. They are approximately 10,000 kilometers in height. One lifespan is from 5 to 10 minutes, and they appear to be shifting up and down repeatedly. Normally, about 500,000 individual spicules are generated over the Sun's entirety at any given time, and it is believed that they emit vast amounts of energy into outer space. Next, look at the upper left-hand corner. This is a gigantic prominence as seen with ultraviolet rays. Some prominences will drift just like a cloud about the upper regions of the Sun. On the other hand, on the right-hand side, a phenomenon that appears to be exploding violently can be seen. This is an area called an active region, a place where energy and substances are being released with great force. This is an image of changes in the Sun's activity as observed successively over approximately 1 month. Paying attention to the detailed structure of the surface, one can see the Sun rotating at a glance. At its equator, it takes the Sun about 27 days to make 1 revolution. This is the appearance of the Sun through ultraviolet rays given off by iron. It captures the ultraviolet rays released by gas reaching extreme temperatures of 1.5 million degrees Celsius. Countless fine lines and brightly glittering places are visible along the rim of the Sun. These show the lines of magnetic force indicating the powerfulness of the magnetic field. Because gas of extreme temperatures of 1.5 million degrees Celsius characteristically moves along the lines of magnetic force, by observing it, we can understand the state of these invisible lines of magnetic force. Let's magnify the brightly shining section slightly below the center. We can see that over several days,